Ground fault circuit interrupter protection is required for all electrical outlets, switches, lights, fans, and other electrical devices in a residential bathroom. GFCIs are designed to detect small imbalances in current caused by electrical faults and quickly break the circuit to prevent electrocution. Each bathroom should have a dedicated circuit. This means that the electrical power for that bathroom should not be shared with other rooms, helping to prevent overloads and ensuring adequate power for the bathroom's outlets and appliances. However, there are exceptions. In some cases, multiple bathrooms can be on the same circuit if they are firstly, adjoining bathrooms such as a master bathroom and an adjacent smaller bathroom, or secondly, both small bathrooms such as half bathrooms or padded rooms. If multiple adjoining bathrooms are on the same circuit, the circuit must be protected by a 20-amp ground fault circuit interrupter breaker. The ground fault circuit interrupter device can be located in either bathroom, but it must be readily accessible and visible. If multiple small bathrooms are on the same circuit, the circuit must be protected by a 15-amp ground fault circuit interrupter breaker. The ground fault circuit interrupter device can be located in any of the bathrooms. It is always recommended to consult with a licensed electrician for specific electrical wiring and circuit design requirements, as local building codes and regulations may vary. Electrical safety in bathrooms is of paramount importance due to the presence of water, which significantly increases the risk of electric shock. Ground fault circuit interrupters are life-saving devices that should be installed and maintained correctly. Their function is to monitor the electrical current flowing through a circuit. If there is an imbalance, even a very small one, it indicates that some of the current is escaping the intended path and could be flowing through a person to ground. A ground fault circuit interrupter reacts almost instantaneously, tripping the circuit and cutting off the power before a harmful or lethal shock can occur. The National Electrical Code, or NEC, provides detailed guidelines for electrical installations, including those in bathrooms. It mandates ground fault circuit interrupter protection for all 125-volt, 15 and 20-amp receptacles installed in bathrooms. This requirement extends to any receptacle within 6 feet of the outside edge of a sink. The purpose is to protect individuals from accidental contact with energized parts or faulty appliances while they are in contact with water or wet surfaces. Beyond receptacles, ground fault circuit interrupter protection is also required for other electrical equipment in bathrooms, such as lighting fixtures, exhaust fans, and electric heaters. These devices, even if they are not directly plugged into a receptacle, can still pose a risk of electrical shock if they have internal faults or damaged wiring. By extending ground fault circuit interrupter protection to these components, the overall safety of the bathroom environment is significantly enhanced. When installing ground fault circuit interrupters, it is essential to follow the manufacturer's instructions carefully. These instructions provide guidance on proper wiring, testing, and maintenance procedures. Ground fault circuit interrupters are typically installed in place of standard circuit breakers in the electrical panel or as receptacles with built-in ground fault circuit interrupter protection. Regular testing of ground fault circuit interrupters is crucial to ensure that they are functioning correctly. Most ground fault circuit interrupter receptacles have test and reset buttons. Pressing the test button simulates a ground fault, causing the ground fault circuit interrupter to trip. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. After testing, the reset button should be pressed to restore power to the circuit. The requirement for dedicated circuits in bathrooms is based on several factors, primarily related to safety and performance. A dedicated circuit is an electrical circuit that serves only one specific area or appliance. In the case of bathrooms, a dedicated circuit ensures that the electrical load from the bathroom's various devices does not overload the circuit or cause voltage drops. Overloading a circuit can lead to overheating of wires, which can create a fire hazard. Voltage drops can cause appliances to malfunction or operate inefficiently. Bathrooms often have multiple electrical devices operating simultaneously, such as hairdryers, curling irons, electric razors, and lights. These devices can draw a significant amount of power, especially when they are all turned on at the same time. A dedicated circuit provides sufficient capacity to handle this load without compromising safety or performance. The National Electrical Code specifies the minimum size of conductors and overcurrent protection devices for branch circuits. For a typical bathroom circuit, a 15 or 20 amp circuit is generally required depending on the anticipated load. The circuit should be wired with appropriately sized conductors such as number 14 or number 12 American wire gauge copper wire, and protected by a circuit breaker or fuse of the correct rating. While dedicated circuits are generally recommended for each bathroom, there are some exceptions where multiple bathrooms can share a single circuit. These exceptions typically apply to situations where the bathrooms are small and have minimal electrical loads, or when the bathrooms are located in close proximity to each other. One common exception is for adjacent bathrooms in a residential dwelling. For example, a master bathroom and an adjoining half-bath may be permitted to share a single circuit, provided that the total electrical load from both bathrooms does not exceed the capacity of the circuit. In these cases, it is essential to carefully calculate the total load and ensure that the circuit is adequately protected by a ground fault circuit interrupter. Another exception may apply to small bathrooms or powder rooms that have limited electrical devices, such as a single light fixture and a receptacle. These bathrooms may be permitted to share a circuit with other non-bathroom loads, such as lighting in a hallway. However, it is still crucial to ensure that the total load on the circuit does not exceed its capacity and that ground fault circuit interrupter protection is provided for the bathroom receptacle. When multiple bathrooms share a single circuit, there are specific requirements for ground fault circuit interrupter protection. The National Electrical Code typically requires that all receptacles in bathrooms be ground fault circuit interrupter protected, regardless of whether they are on a dedicated circuit or a shared circuit. In the case of shared circuits, the ground fault circuit interrupter protection can be provided by a ground fault circuit interrupter circuit breaker in the electrical panel or by a ground fault circuit interrupter receptacle installed in one of the bathrooms. If a ground fault circuit interrupter receptacle is used, it must protect all of the receptacles on the circuit, including those in the other bathrooms. This can be achieved by wiring the receptacles in series, with the ground fault circuit interrupter receptacle as the first device on the circuit. Alternatively, a ground fault circuit interrupter protected circuit can be extended from the ground fault circuit interrupter receptacle to the other bathrooms. It is important to note that local electrical codes and regulations may vary. It is always advisable to consult with a licensed electrician to ensure that the electrical wiring and circuit design in your bathroom comply with all applicable codes. An electrician can assess the specific electrical loads in your bathroom and determine the appropriate size and configuration of the circuits. They can also ensure that ground fault circuit interrupters are installed correctly and that all electrical work is performed safely. In addition to ground fault circuit interrupter protection and dedicated circuits, there are several other electrical safety considerations to keep in mind when working with bathroom wiring. Firstly, always turn off the power to the circuit before working on any electrical components. This can be done by switching off the circuit breaker or removing the fuse that protects the circuit. Secondly, use appropriate wiring methods and materials for bathroom environments. Bathrooms are considered damp or wet locations, so wiring must be protected from moisture. This can be achieved by using moisture-resistant cables such as Type UF cable or by installing wiring and conduit. Thirdly, properly ground all electrical devices and equipment in the bathroom. Grounding provides a low-resistance path for fault currents, which helps to prevent electrical shock. Make sure that all receptacles, light fixtures, and other electrical devices are connected to a properly grounded circuit. Fourthly, avoid running electrical cords across doorways or under rugs. These cords can become damaged or create a tripping hazard. Instead, use extension cords that are specifically designed for bathroom use and keep them away from water sources. Fifthly, never overload electrical outlets or extension cords. Overloading can cause the wires to overheat and create a fire hazard. Use a power strip with a built-in circuit breaker to protect against overloads. Sixthly, keep electrical appliances away from water sources. Water conducts electricity, so it is essential to keep appliances such as hair dryers, curling irons, and radios away from sinks, bathtubs, and showers. If an appliance falls into water, do not attempt to retrieve it while it is still plugged in. Instead, turn off the power at the circuit breaker and then retrieve the appliance. Seventhly, regularly inspect electrical cords and appliances for damage. Frayed or cracked cords can be a shock hazard. Damaged appliances should be repaired or replaced immediately. Eighthly, be aware of the location of all electrical panels and outlets in your bathroom. In case of an emergency, you need to be able to quickly turn off the power or access a ground fault circuit interrupter reset button. Ninthly, consider installing tamper-resistant receptacles in bathrooms, especially if there are young children in the home. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots. Tenthly, if you are unsure about any aspect of bathroom electrical safety, consult with a licensed electrician. An electrician can provide expert advice and assistance to ensure that your bathroom is safe and compliant with all applicable codes. Ground fault circuit interrupters are a critical component of bathroom electrical safety. They protect against electrical shock by detecting ground faults and quickly interrupting the circuit. Dedicated circuits ensure that bathrooms have adequate power and prevent overloads. By following these guidelines and consulting with a licensed electrician, you can ensure that your bathroom is safe and compliant with all applicable codes. Remember, electrical safety is not just a matter of convenience, it is a matter of life and death. Taking the necessary precautions can protect you and your family from electrical hazards.